So hello guys, welcome back to my channel Code with me. So here I am making the video of maths that is used in Python, but I have already covered Python, and I am making the video for the ML machine learning. So machine learning maths is very important, and that linear algebra is very important. So let's get started. The first thing is linear algebra. In that, scalars means something values. Scalar means like it is representing the value. Yeah, something it is representing. Then suppose we have the laptop on sale that its price is 50,000. So 50,000 plus 5,000 is 55. These two are the values. Then next is like you have the 50% discount, then it is 25,000. There is the scalar and is nothing but the value. Next thing is vector. Vector is having the different definition in different, like for computer science it is the list of numbers, and for the physicist it is considered as the scalar with the direction and like uh, difference it in the left side. And for the mathematics it is the combination of both and generalized for everyone, like this r cap is one vector. So the next thing is like linear algebra operations. So yeah, the next thing is like linear algebra vector operations. In that, addition means we are adding the two vectors, like v1 left side, that is in diagram, that is like v1 plus v2, that is the 2. Like adding two vectors is not simple arithmetic, like we are adding the vectors. The next thing, it is the total work achieved through both the vectors in qualified form, like this is the vector addition. It is called dot product. The next thing is scalar multiplication. So it is having the 2, like either it will grow or a shrink. Grow means positive, shrink means negative. So here in left side it is shrinking. Minus k into v1. If it is grow, then k into v1, so it will grow. The next thing is yeah, up to here vectors and scalars are over. So next thing we are starting is matrix. Matrix is nothing but a one row and column form. In that, determinant of a matrix means we are taking a first row, and we are first row first number, it is a, then we are cross finger that, and e into e f, that all, minus then b then c, same like that, and then we are multiplying e into I minus like a e into I, like that, minus minus a f in fourth number, a f g h is there, cross multiplication we have to do. So this is like this, and it is called, it will give eigenvalues of the matrix. Eigenvalues means lastly this equation is called the eigenvalue, product of eigenvalues of a matrix, like that. The next thing is yeah, this is the matrix. So matrix is a combination of numbers, symbols, or a expression that is in rectangular array. So that is having the rows and columns. We use a matrix how convert expression to the arrays. So so our expression of the vectors forms to the array. So we are converting vector form to array. They make operation easier. They make operation easier. Yeah. What we work on a computers like this. So in left side, see, two equations are there. So we have to represent that in matrix form. So the next thing is a linear algebra eigenvectors. I already said what is the eigenvectors is, do not change the direction, even transform means some transformation is applied, but direction is same, but it is here shearing. Yeah, it is moving in the same direction, but it is shearing, before shearing, after shearing. So they are most sensitive parts of a dataset and can be used for this is used for the analysis process. Yeah. Next thing is matrix operation. One is addition, subtraction, multiplication. Here multiplication is very important again, and addition means 2 plus 2 is 4, like that. Same for the subtraction, 2 minus 2 is 0. And for the multiplication, take 2 into 2. See, first matrix, consider first matrix and second matrix. So 2 into 2 plus 2 into 1, like that. First row first column of the second matrix, and first row second column, then second row first column second row, like that you have to do, and do the multiplication. So that is very important. And the next thing is some well-known operations like scaling, sharing, and rotation. We'll discuss this. This is not that important, but some it is used, like for the scaling, purpose. Shearing means we have already discussed. Rotation means it will rotate, like sine, cos are used. Okay. So the next thing is transpose of a matrix is nothing but we are interchanging the 4 and 2 here. See left side, you will understand. So transpose can be used to flip the dimension. To flip the dimension means to like x dimension, y dimension, like that, to flip that. And the next thing is determinant of the matrix. We have already discussed this, and it will give we already discussed this. And inverse of the matrix means if two matrix, one matrix, and that inverse is identity, means one. Inverse helps to apply the transformation easily. Some matrices do not have a inverse, which means that information they hold is not reliable, means it is not correct, very noisy, like that. So the next thing is linear algebra vector as a matrix. So vectors can be easily translated to matrix. So we can easily translate vectors to the matrix. So here see, v1 and v2 are the vectors. So 3 and 4, that is matrix. 1 and 2, that is matrix. So you can easily do that, and they make it easy to apply the operations on a data. Certain well-known operations are, like we already discussed, like scaling, rotation, and shearing. Shearing we already is known. Scaling means it will scale like this, and rotation means like sine, cos, like that. Yeah. So the next thing is we discussed, this one is also discussed. And the next thing is the linear algebra as a matrix. So we are having two methods, one is row echelon method and one is inverse method. So what is that, we'll discuss. So row echelon method means we are adding the operations on row. Here see, here in a first step, these are in the so many steps, you have to remember that. If you can't remember, just go through practicing, you will remember. And it is not that important to remember all the things, but like if you are doing the operations in practically, I will show one coding example, there will understand where we are using. So yeah, this is one like basic you have to remember, like multiplication, addition, and what are the vectors for vector operations and matrix operations, you have to remember. This is step 1 is r1 is equal to r1 by 2. Then step 2 is r2 is equal to r2 minus r1. Step 3 is r3 is equal to r3 minus r1. Step 4 is r2 is equal to 2 by 5 of r2. Then step 5 is r1 is equal to r1 minus 1 by 2 of r2. R3 is equal to r3 minus 1 by 2 of r2. Then r1 is equal to r1 plus r3. R2 is equal to r2 minus r3. You have to remember all this. I know this is a bit tough, but once you practice 2 or 3 times, you will remember easily. So you can remember easily. So the last you have to get 1 0 0 0 at last. Okay. And the next thing is inverse. How we will find an inverse means, this is one example. So how means like see, a into a inverse, I have already said inverse of the matrix identity means 1. So a into b is equal to c. So a we have to take into a inverse. So a inverse 1. So b is equal to c into a inverse. So a inverse how we will find means, first take 1 by that matrix AD, means cross multiplication you have to do, then interchange that and put the minus, so it is the inverse. We already done here. So in this example, not this is different example, so we will done to here. And then eigenvector sharing we have already discussed. And what are the applications means, application is PCA means principal component analysis. For the dimension reduction helps to increase like if you want to increase the quality of data what you are having, for that this is used, linear algebra is used. And working with applying the like for pixel data means in one picture, in image you are having so many pixel of data. For that transformations are used. And the next thing is encoding of a data set, if you are doing encoding, and a singular value decomposition, latent analysis for the natural language processing. We'll discuss it later. After the maths we'll discuss machine learning, and then deep learning also we'll discuss with the projects and all, we'll discuss later. So this is the code you have to remember, not you have to practice this. And yeah, try this in your PC, take a screenshot and try this, must try this in your PC. Must and should you have like PyCharm, or you can do it in VS Code and all. Yeah, make sure that you are having the correct extensions and all. So see, and you have to install pip install like numpy, matplotlib, scalar, all you have to install, then do this operation. So the first import numpy, then import matplotlib, then scalar, like that you have to import this all, then range, specify random state, then x is equals to np dot like that. You have to take random data and scatter that and axis, then show. Then pca is equal to pca of like n components is equal to 2, then pca dot fit of x, and you have to draw the vector. So for that ax is equal, see, arguments are v0, v1 and ax is equal to none. The next is ax is equal to x or plot dot plt dot gca. Then a row props is equal to dictionary. We have already discussed in the previous video. Let's check this and see what are dictionary. This is the key, arrow style, this is the value, then key value equivalent, like that. The next thing is ax dot this, then passing the arguments to that def. So yeah, the next thing is yeah, plot data. So plot data is equal to this x and all for length vector in zip, these two arguments. Then b is equal to vector into 3 into np dot square root of length. Then draw vector, well, plot dot axis equal, then plot show. So we'll show that. And the next thing is same as previous, then combination there 2, here 1. So pca dot fit, then transform, then inverse. First we will take a transform. Transform means exchanging the values of first row second column value, and first row first column second row first column value. We have to interchange that. And inverse means you already know, doing some operations there. Then scatter, then new here, and then axis is equal to equal, then show. So next is land bit is equal to string, we'll change that. And then x is equal to, no, this is the previous that example. And after running this you will get like this. Let's go and run, it will be helpful for you. Yeah, this is the scattering like example which we'll get after doing this code. Yeah, thanks for watching. Thanks for watching. Learn, like, share, subscribe to my channel. This is very helpful for you, and it is very short video, so you can understand all the important topics. I only put what are the important for the machine learning. So yeah, let me give you the feedback and give me what you want to learn. Thank you, have a nice day, thanks for watching.